Okay, so let's get rolling. I saw more people resubmitted their assignment and looked like they were more successful with a little bit more time. And it seemed as though the thing we did last time seemed to be helpful, or at least I hope it was. So I want to circle back a little bit now that all of you have kind of connected JSON up to something. And we have the example of JSON on our in our code, even though we haven't hooked it up to our thing from last time, but we kind of show how it would get hooked up. A couple of classes ago, we were talking about APIs and specifically our modern APIs based on really old technology, these things called RESTful APIs. This thing called RESTful APIs, which are based on old HTTP protocol, which has these 4 functions built into it: get, post, put, and delete. And we mentioned that kind of the idea behind this is that anything you wanted to do related to data stored somewhere, or just a cloud-based database, you can accomplish with these 4 functions and then endpoints. And we're going to kind of see an example of endpoints today. I think I had referenced this before, but I mean, there's lots and lots and lots of APIs out there. I know at the hackathon this past week, the group was working with the YouTube API for pulling down video and you know, the video converted to text, so they had the contents of stuff from a video, and then maybe looking at doing something with it, like passing it into the OpenAI API. So if you want to leverage ChatGPT stuff inside your computer programs, you can do that. You can go sign up for an account with them. You got to put some money on there because each request costs something for a tool like that, where let's say the somethings you're dealing with are something they would charge for in regular life. There's lots of other APIs out there that are completely free. So there's this whole thing about authentication with an API. There's usually an OAuth key or something like that. It's pretty easy to find examples of that kind of stuff. But today, we're going to look at an API that I had mentioned on Pokemon. So there's the Pokemon API out there for no other reason than it's super simple to get to. They have a thing on their website so you can kind of mess with it. So I can show you kind of the JSON. And it doesn't require any authentication. So it's kind of an easy first step into interacting with AI or APIs. With this idea that because we have this standard that the REST has given us, RESTful APIs, this HTTP-based standard, once you interact with one API, you now have the ability to interact with all of them. You can take the code we're going to look at today, and you can use that to talk to 100% of other AIs. Maybe some small little or other APIs, maybe some small little tweaks here and there, where you have to interject the OAuth stuff for saying, hey, here's my API key. I'm allowed to talk to you and you have my credit card on file, something like that. But you do have to consider that all of a sudden the idea of an infinite loop in your code becomes more of a problem. So for example, let's say you are working with the ChatGPT API. So we can even bring that up here. ChatGPT AI API. I'm just going to go to OpenAI.com. I'll go to login. I'm going to say I want to look at the API here. So for example, I have some software that does talk to this API. They have various models. So their most expensive one is GPT-4 Turbo and GPT-4. More capable, yada, yada, yada. Some of these other ones cost less. But if we go to have the costs associated with it in here. One thing you can look at here, so GPT-4 Turbo has a window of 128,000 tokens. So they define this thing called tokens, which you can think of as like words. Well, so whenever you give the AI something, you have to give it the context on top of what it already has. And this is, so effectively you have 128,000 words to make your request. That includes your question as well as their answer. But whatever with all that, but there's a cost per call. Let's see, is cost in here? Chat GPT API cost. Yeah, pricing. So here's our latest thing. GPT-4 Turbo is well, you can break it down, I guess, on a cost per thing. So it's $10 per 1 million tokens, per 1 million words. They do break it down on a per token basis, but you know, every single time I'm asking a question, oh, here's pricing on 1K tokens. Yeah, so for 1,000 tokens, it cost me a penny to talk to this API. Well, let's say I write a computer program that's hitting this API, and I have a while loop, and I forget to change my Boolean expression, and all of a sudden it's an infinite loop. Yeah, it's a penny per a minimum of a penny per call, let's say. Some of the other ones have actually smaller costs than that, but we'll say it's a penny per call. Well, all of a sudden, how many times do you think my computer can hit ChatGPT's API in 1 minute? Thousands of times. So might it be a problem if I have some bad code and I hit an API that's charging a credit card something thousands of times, a penny per shot? It's kind of back in the I say old days. So when I was when I first started driving at the gas stations, they didn't have the thing that automatically shut off the pump. You know, when your thing was full. So it was like somewhat common. I mean, people were used to paying attention, but that, you know, you would see a car sitting there with just fuel dumping on the side of it because they were, you know, they were in buying a bag of chips or something like that. So it wouldn't go off, and all of a sudden, you know, I think typically the way they handled it was the gas pumps had like a maximum price on it of like $75 or something like that, which nowadays you might not be able to fill your tank depending on the car. But in any case, that's what they did, is they put a hard limit for the maximum you could spend. The same thing's kind of true here with most APIs, is they have a hits per second type thing. Now, I had mentioned to you that I already have some code that works with this. I want to show you something related to that. Is it over here? So here's like an example of API keys where you can create them here. Here's usage. Okay, so far this month, I've done $18.58 of requests from my software. But as you use this guy, you move up to, is it under, maybe it's here. You're on different tiers. They have a different tier setting thing. So I'm like on tier 4 or something like that, is under limits. So here's one example. So they have it set up for 5,000 requests per minute is the cap, unless you move up to one of their higher tiers. Do they talk about the tiers down here? Yeah. So I'm currently in tier 3, almost to tier 4. So once the following criteria is met, so at least $250 spent on the API since the account creation. I'm getting probably pretty close to that. and at least 14 days since you first gave them money. So before they let you make more requests. You can request an exception if you need to make more requests, but effectively this is the gas pump protection thing. So 5,000 requests per minute is the cap by default. And if you hit that, at the very least, you're stopped at 5,000 requests, which would end up still being a good amount of money with the for loop. So all of a sudden your bugs in your code have a little bit more meaning. So a good rule of thumb for working with these things are do practice runs of it. Maybe don't put calls to an API inside of a loop initially. Certainly don't put it inside of your update function where it's gonna where it auto you might have perfectly written code that you tested in one run once, and then you just chose to drop it inside of your update function. And now the very first time you run your program, it's gonna, in 5 seconds, it's going to end up calling that API 500 times or something like that. So you do need to be careful with stuff like this where there's charges associated with it. Good news for us is the Pokemon API does not have, it probably has limits because it's not running on the type of machines that this guy's running on. But here's their API somewhere here. Check out the docs. There's probably some limits listed in there. But the idea here is we have a endpoint. Now, I had mentioned that the default, when you are getting information, you're probably going to be using a GET request using HTTP. GET requests are the default requests in a URL. All right, so you can hit any GET endpoint as long as you don't need an OAuth or something for authorizing with it using just a web page. So if I take that, I open up a brand new page here, paste that in. Let's see what that guy just gives us. Okay, so if I just hit that, I press enter, it just made a GET request to the API at the top level, and it's showing me all these different places that I can go for different things. If I want to find out about all the abilities, here's a API for just the abilities. So if I hit that, it's going to give me this guy. So there's 367 different abilities. The next, so it's going to give me 20 at a time. It actually gives me as one of the parameters. This is the JSON document, right? That's JSON. We've already seen that bunch of name value pairs. So this JSON thing says we have 367 different abilities, presuming we know we're getting abilities here by this endpoint. So when we say endpoint, what we're really talking about is this piece here. So the API lives at this base address, and then we have endpoints that we can hit that give us different information. So this endpoint would be a GET request for getting the abilities. Now, it's only showing us 20 abilities at a time, but we can get all of these abilities by calling this multiple times. So notice it says, well, I can call this guy, which will give me, since it's showing me 20 initially, the next set of 20 is at this API call. So an offset of 20 with a limit of 20. So if I click on, if I put that in here, it's going to give me the next 20. All right. So then you can look at what's next. Next is an offset of 40 with a limit of 20. So it keeps telling you can just walk the chain until you're done. And if we do 367 divided by 20, there's going to be 18.35 of these screens that I would launch. So 18 times 20 would be an offset of 360. So I can come up here and I can say offset of 360, limit is equal to 20. And this gives me those last 7. See how that works? Okay, so these are just GET requests, which are very easy to test here inside just a web browser. Otherwise, there is a tool called Postman. Let's see, I think I have I already have it on this computer. I do. At least I think I do. Maybe not. Looks like maybe I have a very old version of it when it tried to launch it. Didn't launch very well. So let's see. I'll just go here. I think this will give me what I'm looking for. Well, so Postman allows you to make API calls. I'm used to dealing with it as a local application. Maybe they've changed their model, whatever, for it. Okay, so this lets me do what I want to do. So for example, I can come to Postman and I'll just steal this URL thing here. So notice here, you can choose your different HTTP requests: get, post, put, and delete. These other ones are kind of not part of the original HTTP standard, but have expanded on it a little bit, probably are not overly used. So I can go ahead and I can paste in my call here, and notice it's already noticed what the different variables are. I can go ahead and click send, and it gives me the response down here. In JSON, it's a little bit nicer to look at or something like that. You can look at just the raw data. Otherwise, it shows it to you in a pretty format. Whatever, it lets you mess around with this. Well, we already saw we can do GET requests just from a normal web browser. What we didn't see is what if we need to do another kind of requests. So for instance, a post request. Well, a post request, you can give it the additional information here. So, you have your parameters. Here's authorization. So you can put in an API key or something like that. If there's stuff you have to add to the header, for instance, like you have to give it input in JSON format or something like this, this lets you do that whole thing as well. So effectively, when you're working with an API initially, GET requests are easy to work with because that's all just normal URL stuff. But doing posts and put requests, which are things that you very well might need to do as a computer programmer, Postman is a good tool for making sure you understand the structure of the JSON without writing it into your computer program and having to make some calls that might be more difficult to test or something like that. Because posts and puts and deletes are much harder things to. You could certainly create your own web page with a web form that has a action for put or post or delete in it and make this work, but it would be a lot more difficult, where Postman gives you the ability to make sample calls very easily. All right. So anyways, we see how we can kind of use this guy, and actually I'll go back in here for it. So the JSON object for this guy comes with something called count, comes with something called next, which is the next URL. In this case, it's null, so we know that means it's at the end of the list, right? We can walk the tree of calls, so we can get the previous URL to get the previous 20 elements. Well, then here's our results. And remember when we talked about XML versus JSON, one of the things that probably the biggest differentiating factor in terms of capability are collections, arrays of things. So here's our actual results of this. So open square bracket is a collection. Inside that collection is a bunch of plain Jane JSON objects. Opening curly brace, name value pairs. So we have this thing called Flame Boost, and it has a URL at this certain thing. So that's actually the ability 10054. If I click on that guy and then I hit send, it's going to make that GET request. So it shows me what a, so this guy, oops. So this guy has a whole bunch of things that start looking a little bit similar to what we had. So this affects changes. So this is the list of stuff that it changes, which is nothing. I don't know what the generation stuff is. Maybe it's a version of this guy. I can follow the link and probably figure it out. Here's the unique ID for this ability. The name of it's Flame Boost. Whatever. So this guy doesn't seem to do tons. Otherwise, I can jump into it further and go and explore the API through this thing and see what are the pieces of information I might want to pull out. All right. So going back to our previous screen, here's our results. We have a collection of ability names. So even though each of these is stored as a JSON object, at this point, we'd only really be interested in the name of the thing. So name is Flame Boost, Aqua Boost, Run Up, Conqueror, yada, yada, yada. So there's a bunch of these. There's 367 of these. We can go ahead and move back and forth through that list. All right, so Postman is a good tool for allowing you to explore an API without having to run a whole bunch of code. There's other tools like this as well. All right, so let me go back to my. All right, so if I just do this call, which I think was that my first guy here? Yeah, this guy. Flash Pokemon. All right, so I can do the Pokemon endpoint on this API call, and this is going to give me a list of my Pokemon. So JSON object, it says there's 1,302. Now this is going to be pretty common for how APIs might end up working because, I mean, in this case, there's 1,302 Pokemon. And even though we're dealing with text, and that's not tons and tons and tons of text, I mean, when you look at this string right here, each one of those characters, if it's in Unicode, is taking up 16 bits, 2 bytes of data. So you can multiply by that. That's the amount of data per count for storing this text. So if we have 1,302, let's see how many things are in this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's call it about 100. So this would be 1,302 times 100 times 8. That's the number of bytes divided by 1,024. That's the number of, actually, hold on. That's the number of bits. No, number of bytes for those things total. Total number of bytes to represent all of these guys, roughly. So divided by 1,024 is kilobytes, divided by 1,024 is megabytes. So it's almost 1 megabyte of data is what is the full list of all possible Pokemon. All right. And you might be able to manipulate this a little bit if I take this string here and I paste it in there and I go and make some slight modifications. If I say offset is 0, and then I say give me a limit of 2000. Let's see if it'll give me all of them. Yep. So I could force it to give me all of them at once, if that is of interest to me. All right, make some sense? All right, so just an example, you can sit there and play around with different APIs. Let's go look at the code that allows you to work with this. First rule of thumb. So what I did is I created a script here. I put it inside of our mono behavior scripts, and I just created a folder called API scripts, and I called it Pokemon API. Go ahead and open this guy here. All right, now C# has its own built-in networking class, but Unity does as well. And whenever there's an example of Unity having its own built-in thing for something, for instance, random number generation and things like that, it's probably best to use Unity's version of it, because they probably made some decisions focused on game performance. However, they're doing the network calls or something like that. So we are looking at, we have to bring in collections. You'll see why here in a second. We have our engine. We have our networking part of the engine. So we're going to do this inside of a coroutine, which is like a multi-threading type thing for Unity. We've seen these before, but I'm purposely doing it this way rather than putting it inside of, even though this is a mono behavior, rather than putting it inside of the update function, where it would do this every single time the frame, which frankly wouldn't necessarily be a problem with the Pokemon thing, other than I'm sure there is a pretty low limit on the number of requests I can make per second or per minute. So it would probably spit out a stop bothering me error message at some point that you're yelling too much. All right. So we're going to pass to our start routine a string representing our URL, and we have a function called getRequest, which will go and this guy right here, which is going to take in. So we're just going to start the coroutine around this getRequest, passing it the string. So we're passing it the Poke API, blah, blah, blah. Same thing we had before with our Pokemon endpoint. We're going to call getRequest. So we're using this web request. And we're going to call the get function. So if I went to Unity web request dot, notice we have a delete, we have a get, we should have a post, we should have a put. So we have our various RESTful API compatible HTTP calls. So in this case, we've proven that this is a get request. If I go just to show you a way you can look at APIs, let me go back to this is the tool for ChatGPT where you can make, test your things, but they will charge you in there. I'm just looking for the API calls. Let's just do OpenAI API endpoints. Here's our reference. So it tells you how to do your authentication. Here's our endpoints. So our chat endpoints. So notice there's endpoints related to audio, to chat. So our chat endpoints, we have a post request for chat completion, where I pass it a message, and it gives you an example of what this might look like over here. So I might say, I want you to give me my answer in JSON. here's my authorization, and you pass it the API key that you generate in here, and then you're giving it as input a JSON object. So this is us sending that as part of our post request. So we're saying we want you to use the GPT 3.5 turbo model, which is cheaper per call. And then you're going to give it some messages, which is a collection. You're going to say the role is system. The content is, this is where you would ask your question. So maybe you wouldn't say you are a helpful assistant. You'd instead say, give me the last 10 teams that won the Super Bowl, or whatever. Whatever you would ask ChatGPT to get a fairly small response so you don't pay for too much, that type of thing. So you build that type of thing, and this is what the response would look like from it. So this is just one of the endpoints. There's all sorts of endpoints that have different things. So like under audio, this is also a post request. They don't have put or and actually what's interesting here is when I advertised post requests, I said it's when you want to store information. It's really when you're sending a request to it. It's probably not storing our request here. What it's probably doing is it's taking as input, and because we have to give it so many pieces of information, not just a string, but we're giving it multiple pieces of information in the header, so the authorization token and things like that, they've done their endpoints as a post request. So you can look at the documentation and see what different endpoints there are, and then choose which ones work for what you want. Pokemon probably has something similar in here. All right, so back in our code, we're going to be using this web request, which is going to do a GET API call on whatever endpoint you passed in. Then it's going to make a call to that web request, which takes time. Okay, so it is going to wait for this guy to return. Now, it's not going to take tons of time, but imagine if you had that inside of an update function, every single frame, it would be making another web request. So now you're effectively doing a denial of service attack on Pokemon's API. Denial of service being that most computers can only take so many incoming requests at once, and each one of those requests is probably being handled by a thread. So when and that, well, hopefully it's a thread and not its own process, because if it's its own process, that'll then take a process ID on that operating system. And next, after, if you're dealing with any sort of a little bit older operating system, after 65,536 requests, they're out of unique application IDs. So now the system administrator can't even open up a terminal to start killing off your open processes for your requests. So you can imagine how dangerous working with APIs can be, especially if you have a credit card associated with it. So just keep that in mind. So in any case, we're going to make our request. We're going to wait for it to finish. Then we're going to ask ourselves about our web request. So the web request has some things in it. We're going to say, well, was the result of it a connection error or a protocol error? Did something bad happen is what this if statement says. We don't expect to get in there. Instead, we expect to get into this else. So what are we going to do? We're just going to print out the web request from its download handler, the text. And what we get is output from that. I still have no, I'll just run it again. Okay, so I ran that guy. If I go to console, here is that, here is that JSON that came in as the response. So now I have a JSON string that's basically just like the JSON string that we had written by hand previously, right? If I want to get a bigger response, and you could certainly write the code that keeps calling the next one and the next one and the next one and the next one, which would be a fun thing to try. I think we'll see here that we can, I did it in, was it this one? Well, I can just modify that. So go back to our code here. I'm just going to change this URL I'm passing in. And we're going to give it an offset of 0 and say limit is 2000. So the most numbers I'll take in at once is 2000. I'll go ahead and run this guy. And this should be our whole thing here. I know it's super tiny text for you, but it says count 367. Next is null. Previous is null. So we're getting the whole rigmarole there. Okay. So if we wanted to bring this data into our code, let's go back and just look at what we're getting here from this guy. So actually, I think we liked it better in here. Let's just look at it a little bit cleaner, I think. Well, let's work with this. All right, so our response is a JSON object that has 4 pieces of information in it. A count, a next, a previous, and a result. That's that JSON object. We go back to our code and we remind ourselves what our previous JSON object looked like. For item, we had to write a class that mimicked item here, where we had a name, a stat impacted, and a modifier. And that lined up to, is this our JSON one? Name, stat impacted, and modifier. Technically, ours would be broken right now because we don't also have a cost in there. So since this has a cost and cost is of type int, we would go in and make a change to this guy and say that we also have a public int cost. Int cost. This dot cost is equal to cost. We could certainly change the way we're displaying stuff, whatever. But now this guy represents what is in our JSON. If we're going to write the same type of thing for our Pokemon, all right, now we're going to have a, let me just look at the nature of the data real quick. What will we call this guy? So under results, these are abilities. Let me change this to Pokemon. Oh, okay. So here would be an example of an error message because I still had this set up as post. So I'm going to switch this to get, make that call again. All right. So now we have a JSON object that has a count, number of Pokemon, a next, a previous, and then our results. Our result is a collection of what? Of Pokemon, where a Pokemon has a name and a URL. All right. So if we were to go write the code for this guy, floating controls. I'm just going to copy that guy so we can make a modification from it. I'll go back into Unity here. And in our API scripts, I'm going to go ahead and create a C# script here. And we're going to call this guy Pokemon. I'll paste our other thing in there. Did I not bring enough stuff? So it's going to be class called Pokemon. Now I'm going to have to match up to what this guy's going to have in it. Now, we were just looking at our code and we see that here results will be a collection of Pokemon. So Pokemon is a name and a URL, which are both strings. So we're going to kind of work backwards. So we have a name, we have a URL. Make sure your constructors name the same as the class. All right, so we've modified it for this. And then we'll go ahead and update our display to look right. All right. So we also have a couple of other things in here. We had this thing called a root object, but that guy's a collection of items. Instead, we want this guy to probably be a collection of Pokemon. So let's call this guy a collection of Pokemon. And we're going to have in here we can call it the actually for this we want to call it results. That's what that guy came in as, results. Now we're also going to have a count, a next, and a previous. Count, public, next and previous. Ay, going so slow. Make sure they spelled out previous. They did. And both of those are strings. Notice that a possible value could be null for next. So that is an empty object. It's not the string null. It's literally nothingness. And then results, which we see are a collection of Pokemon objects. All right. So our collection of Pokemon looks like this. All right. So if we go back into our code now. And we look back at how we did this for items. Our JSON object, our root object. We used to call it root object. And we just updated our code for the Pokemon to be collection of Pokemon is what we called it. So our root object here, which is the top level thing, only had one name value pair. It had a name called items, and its value was a collection of stuff. Similarly, one of the four things that our collection of Pokemon has, that's this whole thing, is a collection of Pokemon. It's going to have a count, a next, a previous, and then that results will be our actual collection of Pokemon. All right, so we've added three things to this guy that weren't there before. I think it was in our shop code, right? So here was our shop code where we actually read in our JSON string. Okay, so our homework for next time is going to be to read in from our Pokemon to show that on the screen, in some sort of format that you were able to read in all the Pokemon. So this is going to have you understand how our reading from a file worked, but now instead of reading from a file, we're reading from a URL endpoint. So we'll have our JSON string. This guy will come in from some source. Right now, read items data JSON is doing file IO instead of network IO. Okay, I've given you now an example of doing network IO, where instead of this guy returning the string that it read in from a file, it's now going to go out and get its JSON string from a URL, which I have in the code here. Ultimately, build up your string from your response, which we've already seen. We go back to our I put it inside of our collection manager. So the collection manager has, that is where I put it, isn't it? Oh, no, I put it inside of something called Pokemon API. And what I did is I made that guy a attribute of the collection top level thing. You could put it wherever you want, but I just made a mono behavior, added it to that guy. So when this scene starts, it will call that code. That is this guy. Inside of start is where I call my coroutine, which does this thing. And ultimately, this thing is going to be the guy that's going to get our string right here. That is the JSON string. So for your homework, you're going to take that JSON string. You need to attach it to your classes that we've already written the base class. So you just need to get it to fill that guy. Then go through and you can print to the console all of your Pokemon in terms of their name and in terms of their the URL. We already built that Pokemon class for that. It knows how to hold a name and a URL. We already have an example of doing this for our items. And then we've created a second class in here called our collection of Pokemon. So instead of calling it root object, it's called collection of Pokemon, and it holds those 4 pieces of information: count, next, previous, and then the collection of Pokemon as an array of Pokemon. All right, so homework. Update. Well, here, let me steal this part of it. Update your code to read in the entire collection of Pokemon and display to the screen. Well, let's see, and create a series of object instances to match our Pokemon collection, and then loop through that collection to display the individual Pokemon to the screen in terms of their names and URLs. Okay, proving that you can get this information. All right, so I've basically given you all the pieces. I just haven't connected them together. Make sense? All right, questions about what I'm asking you to do. And now keep in mind that this exercise will now unlock your ability to talk to any API. So hopefully this starts getting your creative juices going if you're not as excited about Pokemon as I am. About looking at some other APIs, maybe along the lines of a video game that you're interested in. A lot of the video games have APIs that have information about it, that kind of stuff. So you might check around and see, hey, what data sets might be out there that I might want to write a stupid program around that uses that data set to do something. Finding cheap flights. It's another thing. There's a lot of airline APIs out there where you can get in one spot. I mean, where do you think Google gets their flight data from? In fact, Google Flights probably has their own API. All right, make some sense? All right, I'll see everybody on Wednesday.
Hey, Dr. Whitman.
What's up?
So, so my family is thinking of giving